For those of you who are joining us for the first time, this is part of our Productivity Web3 initiative, where we are trying to upskill all of the consensus employees, but also the whole community and everything that's happening in Web3. So we run educational sessions. We try to run interesting demos and engaging chats and fireside chats with top minds of the industry. And we've been doing this for over a year now, actually, on a monthly basis, on every first or third. It used to be Thursdays. We moved it to Wednesdays now. So every first or third Wednesday of the month. And Connor is here as well. So yeah, so we've been doing that for a year, and we decided for the next 2 months to do an AI takeover in line with everything that's happening in the ecosystem. And it is my pleasure to start the first of the 3 talks of today. That will be focused on AI and impact of AI on Web3, or just what we do with AI. How can we increase our productivity in Web3 or not Web3, in Web2, in Web8, whatever you want to call it. So it is my pleasure to host today Connor Hagen, who's leading Microsoft efforts on AI. And Connor will do a little presentation or a lecture on various AI topics at Microsoft, and we'll have plenty of time for questions, I'm sure. And if you want to ask a question, before I hand it over to Connor, if you want to ask a question, there is a Q&A at the bottom of the screen. You can type in your question. If you'd like to actually speak up and say something as a human and prove that you're not an AI bot, then raise your hand and I'll allow you to speak, and you can have a personal interaction here. So having said that, Connor, it's my pleasure again to host you. Thank you so much for making the time. The floor is yours.
Thank you everyone for joining. I was having difficulties coming up with the title that I felt really all-encompassed the different topics I wanted to talk about today, but I landed on Power Your AI Transformation with the Microsoft Cloud. We're going to be covering a lot of topics. I work in the field of AI, so we're going to be touching on a lot of different topics, including how Microsoft is using AI, and how we've seen some of our AI success stories recently with our customers. First, a little bit of background about me. So my name is Connor Hagen. I'm a senior business development manager in the AI and emerging technologies business development group. I have 7 years experience architecting and developing Azure solutions as the lead architect in Microsoft's AI Co-Innovation Lab. The AI Co-Innovation Lab is a global organization. We have 4 locations around the world where we enable our customers in any sort of AI solution they want to build on Azure. So whether that's developing a POC or taking that proof of concept and moving it up to production, we help them fill in the gaps of their knowledge around cloud or AI and teach them best practices as we've grown to see best fit over the past 10 years where the lab has been around. I specialize in AI, data science, and machine learning. I have an academic background in AI, built hundreds of AI solutions with our customers as part of that lab. And just like a little more context, so previous to 2021, I was working primarily with the lab on some of our older kind of AI applications, things around like the Azure Machine Learning Service. I'll show you. So this is the AI Co-Innovation Lab that we have in Shanghai. So I would be building some of these AI solutions around things like computer vision or predictive forecasting, and I saw a shift happening in early 2021, and I decided to move into business development because I saw a strategic partnership with, at that time, a little-known service called the Azure OpenAI service, where OpenAI's models were being deployed as inferenceable APIs to the Azure cloud. So I saw a tremendous amount of capability and value with, at that time, the latest model was GPT-3. I had no idea how powerful those models were going to get. But even at that time, with just GPT-3 and the Codex models, I was going to do my best to share it with anyone who would listen. So I was leading the efforts with Azure OpenAI, and we had a couple interesting strategic partnerships. And it wasn't until December of 2022 rolled around that we saw the release of ChatGPT, and finally, I felt like these models were getting the recognition they deserved. But with any technology this novel, there is an inherent learning curve for everyone, like even the experts. So this learning curve around like how to build something with best practices. So at that point, I had been away from the AI co-innovation lab for about a year and a half. And I was called back into the lab to shepherd the lab through this new era of AI, which for me is like a huge win-win. Like, one, I get to work on the cool technical things again. And two, I get to see how our customers are actually using these things. And I get to watch an ecosystem grow from the ground floor. Like the capabilities of these models are so interesting and so new, that yeah, we're having to figure this out kind of as we go. And I hope today to share some of the learnings with you. One more slide around the AI Co-Innovation Lab. So we have 20 dedicated experts. We expect that to grow over the next year as we open 2 more locations. You can see on the right here, we have like a bunch of previous engagements with large companies, but we also have a ton of engagements with other smaller companies like startups and stuff. So here's what we'll be covering today. First, I'll be talking about AI at Microsoft. This is the different ways that you can take advantage of these new AI models in the Microsoft ecosystem, and sort of some of Microsoft's philosophy around the new era of generative AI. Second, I'll be talking about some of the new tools, patterns, and skill sets. This is like a higher order level of understanding of how we've had success building with these tools in the past. Next, I'll talk about some common advantages and blockers. As customers come in, there are some common things that they can bring to the table where it enables us to move a lot faster, or there's some things the customer comes in and we say, hey, you have to figure out X, Y, and Z first before we can really start using these models. And of course, I want to leave a healthy amount of time for Q&A. I'll also, I asked Marta to interrupt me between slides if we see any good questions. So let's begin. One big asterisk: things in AI are changing fast. So anything that I say today might change in the future. I've given a lot of presentations over the past 9 months, and I can safely say the things that we thought to be true in January slowly evolve to March, evolve even more to June, and we're just going to keep evolving. I think there are some fundamental things here that will stay static, but the way things are changing right now, you really have to be on your toes and be ready to adapt and learn as these things grow. Another big asterisk, and this one is specifically for this audience, I have minimal experience with Web3 technology. In that I know enough about Web3 to know that I do not know enough about Web3 to speak confidently on like how AI is going to specifically affect Web3. However, I do have a reasonable amount of certainty that the recent progress we're seeing in AI is exhibiting increasingly far-reaching effect on every industry that I've encountered in my time working with Microsoft's wide customer base. And so I do believe that now is the time for deep pockets of technological advancement to begin collaborating. So while people are digging their technological advancements down into the field of Web3, I've been over here digging my deep hole into the technological advancements of AI. And I hope that through collaboration, we can start to dig towards each other and meet somewhere in the middle where we can find some collaboration where advancements in AI will affect Web3, and in turn, advancements in Web3 will affect AI. I think that there's a lot of powerful potential for things like that. So let's talk AI at Microsoft. We have re-bundled some of our AI services. We like to have one place now where you can come to build and run AI, and that's the Azure AI Studio. So the Azure AI services, formerly called the cognitive services, these are pre-built AI capabilities through customizable APIs. So this includes the Azure OpenAI service, where Microsoft has exclusive distribution rights to the Azure or to the OpenAI series of models, your GPT 3.5s, your GPT 4s. But it also includes some other super useful services, such as our language services, where you can do translation or speech to text, text to speech. And we have a few interesting computer vision services there as well, where you can train your own computer vision models on your own custom data sets. So those are like the high order level of Azure AI services, where the bar is really low for technical expertise. Like we don't think you need to retrain a language model every time that you want to take advantage of speech to text. Like that is a generalizable enough problem that we should just be able to train one model really well and then expose it to anybody who wants to use that model. The second level here is like a little bit lower, where maybe you have the technical expertise to build, train, and fine tune your own specialized models. So this is like you're bringing your own data, you have your machine learning architecture, and you're looking to train a model for forecasting or computer vision. We have the Azure Machine Learning Platform, where you can do that really easily in one user interface or through the CLI. And you can have some great collaboration tools in there as well, where you can track the progress of your models and start to share the progress you've made in a scientific environment with anybody else who you're sharing that platform with. And the final level down here is the Azure AI infrastructure. So this is like the bare metal. You want to train an AI model directly on our AI infrastructure. Maybe you're building your own large language model and you want access to 1,000 H100s. We have the AI infrastructure to support that, and we are constantly building new data centers to be able to support the scale that we see necessary for the demand of individuals who are and organizations who are building their own Azure AI models. We also have what's called the Copilot stack. So as you're thinking about what you'll build, we've introduced this way to think about how to build your own Copilot. The Copilot name started with the super useful GitHub Copilot service. And we have broadened it now to be able to build Copilots for your own applications. And we have a lot of Copilots that Microsoft is building for our applications. So you'll start to see PowerPoint Copilot, Word Copilot, Outlook Copilot. And we call the tools and orchestration around this the Copilot stack. And it's an application development pattern that can help you conceptualize how to bring together these next generation foundation models with your own data and the powerful AI infrastructure below this in the Microsoft cloud. And the AI orchestration that helps you tailor the inputs and outputs from that foundational layer, combined with the user experiences that draw on this stack, all of that together is the framework that we are putting together for the Copilot stack. So this stack and the way that we interface with this is an artifact of Microsoft building all of our own Copilots, right? We had all these Copilot solutions that were rolling out, and we found some really common patterns between them, and we decided like, hey, we want everybody to be able to build their own co-pilots. So we've open sourced a lot of this stack to be able to build these co-pilot solutions on your own. And we'll see a lot of interesting integrations in the future with tool sets such as semantic kernel. And now I could go more in depth about Microsoft's Copilot ecosystem. It's something I'm passionate about. But honestly, it's such a deep topic that it could take an entire hour to itself. So, Marta, maybe there's like a future session in the series addressing what's so awesome about the power of copilots.
And one question on the copilots: is copilots only or copilot only for coding, or are there copilots for non-coding applications?
Yeah, so it began with just a coding copilot in GitHub Copilot, but now that has been broadened to copilots in any of your applications. So the way that we interface with the GitHub Copilot is by asking the Copilot to assist using natural language, right? We say something like, write some code that connects Outlook to my whatever server to download my emails. And GitHub Copilot can write the code to do that. If we want to extend that to other applications, it would be like asking, hey, based on this email, write me a 3-slide PowerPoint deck outlining the main points that we need to address with the customer. And the Copilot, the same way that it would write code in GitHub Copilot, will now be able to write a first draft of this slide deck based on the natural language prompt that you've given.
That's very cool.
Yeah, yeah. And we'll be seeing a lot more of these being rolled out soon, and I expect a lot of as we start rolling those out, we have been getting a lot of interesting customer engagements where customers are seeing the value of this and they want to build their own copilots as well. So it's a very exciting time. The strength of these apps or Copilot agents that are being tied to the Azure OpenAI service, a lot of the strength lies in the data that is being used as grounding knowledge for the responses. So when we start developing with the Azure OpenAI service, or I'll take a moment really quick to just like add a little more context to the foundation models as well. So we see on the slide we have the Azure OpenAI service, but I also want to say that like Microsoft, we made a big bet on OpenAI, so we really do believe that their models are incredibly powerful. But we also understand that there's a lot of other foundation models out there that are incredible as well. So you'll see in the Azure AI Studio, we are beginning to give access to other foundation models as well, such as the Falcon series of models. Llama 2 was just recently put into the Model Hub. So this foundation model layer here in the middle, the Azure OpenAI service on your data, could be replaced with any of the other foundation models in Azure. But it's the conduit through which the data sources on the right are being ingested and exposed to the user through natural language in the app or the Copilot agent on the left. So let's talk some of the new tools, patterns, and skill sets. So over the past 9 months, we've built approximately 50 different solutions in the field of generative AI with our customers. We've learned a lot. And also the tools that have been released to enable these kind of solutions have grown, evolved, and embedded themselves in some of these, the AI communities. So there's a paradigm shift that is happening that I really want to encourage anyone who's interested to begin understanding how the way we think about intelligent apps is is changing. The current AI apps have some constrained interactions, hard-coded and fixed data sets, and to change these models is costly and complex. Classically, these models, when you would train an AI model before the generative AI era, you would have to retrain these models from scratch or fine-tune. You could fine-tune models as well. But either way, when that training is done, that model is static. And so it only incorporates the data that is up until that point of time of the training. You don't have access to data that happens past that. There is a shift happening now where it's a lot easier to quickly deliver access to new data, incorporate new data into your intelligent apps, have this easy natural language interaction where users don't have to be experts to interact with your intelligent systems. And we have these data-driven, personalized experiences that improve over time through whatever kind of feedback loops we're able to inject into the system. Some of the top use cases for generative AI that we've seen come into the lab and that we've seen have a lot of value. We have things like the enterprise chat GPT. Enterprise chat GPT scenarios are very much similar to what we talked about, where an organization can securely and compliantly use natural language prompts to quickly and effectively knowledge mine or find the information they're looking for, ultimately improving productivity, job efficiency, and satisfaction, all while reducing costs. So we have individuals who are able to access the knowledge that they're looking for that may have required a team of research experts to go track down. Now we can have that surfaced a lot easier for the experts to be able to access that knowledge. We also have a lot of success with intelligent call centers. So these are organizations that are leveraging chatbots and virtual assistants to provide instant and accurate responses to customer queries. So if a customer reaches out, they have a question, our generative AI solutions can augment this system by being the first line of defense to be able to answer some of the low-hanging fruit questions, and also act as a co-pilot to the intelligent call center agents to look for the information that they would need for some of the more difficult scenarios. We also have content generation. So this can be typically time-consuming, resource-intensive, and in my personal opinion, the worst part is how repetitive it can be. Generative AI algorithms can automate that content creation process, allowing businesses to generate articles, blog posts, and other written and visual materials quickly, enabling these organizations to save time while accelerating the pace of innovation. Finally, in today's world, we all know that personalization increases the chances of customer engagement. Generative AI can enable businesses to deliver hyper-personalized campaigns by creating dynamic content tailored to an individual's preferences. So that's super optimized for engagement and conversion rates. So here's all these different ideas. I'm sure your minds now are swimming with different ways that you want to see if you can get some value out of these models. But like, where do you start? Right? There's like so many different resources out there. And luckily I can help you. It all starts with knowledge retrieval. I believe that every natural language problem, eventually, if you abstract far enough away, maps back to search. So we need to first and foremost combat the problem of hallucination. You might have heard this before, where these models tend to speak confidently about a topic, but then if you check why the model is saying what it's saying, you realize like, oh, it just made that up. And it very convincingly said something that is just not true. That's a problem, right? We can't have that in a solution that we're serving up to our customers. We need to find a way to mitigate and make sure that hallucination is minimized, if not completely eradicated. And that's where this knowledge retrieval architecture comes in. So instead of a generative AI model responding with an answer to your prompt and you just accept it as true, instead, what we're going to do is the first pass is going to go out. Once it receives your prompt, it's going to go out, try and find the relevant information that could answer your question, and then use that in the prompt as context to answer the question that you are asking. So this prompt and knowledge response is great for two reasons. One, it grounds our responses. So now whatever the service is providing back as truth is now based on something that is in your knowledge database. And two, it provides a citation. So you no longer just have to take the model's word for it. You can actually see why the model is responding the way it is. And so these knowledge retrieval architectures serve as the base for more nuanced use cases, such as retrieval augmented generation. And here at Microsoft, we call this retrieval augmented generation. But I think that there is, in my experience, if while you're learning a new concept, or while a concept is evolving, and you realize that there's a pattern out there that has a bunch of different names that nobody can agree on, that's usually something you should pay attention to. So let me back up. Here at Microsoft, we call it retrieval augmented generation. But if you go out into the field, you'll hear this called a bunch of different things. Some people call it knowledge retrieval. Some people call it semantic search. Some people call it prompt hydration. So when I say that like it's something worth paying attention to, I'm saying it's worth paying attention to because if a bunch of different people have a bunch of different names for it, what that probably means is this pattern emerged independently among a bunch of different groups, and they all gave it their own name. And now we're all trying to figure out what to call it. So in this slide deck, I call it retrieval augmented generation. In most Microsoft content, you'll see it called retrieval augmented generation or RAG. And those are all arrows pointing back to the same thing, which is this this architecture where we are retrieving grounding knowledge and using that as a reference for our model. And those are all a lot of the success we've had in the AI co-innovation lab has been with the embeddings concept of knowledge retrieval. So there are embeddings models in the Azure OpenAI service where you can translate your query or any concept, any string of characters into an embedding that is then compared against a vector database full of other embeddings to find which other item in that vector database is most similar to the question that you're asking. So this is one way that we can go into a knowledge database and find the most relevant information by comparing the distance between these embeddings. And I don't think it's generally available yet, but I think you can use it in public preview. The Azure Cognitive Search now supports a vector search as well, so you can do this knowledge retrieval all in the Azure Cognitive Search. Martha, I wanted to take a breather if we have any questions.
we do have two questions. Actually, the first one is probably the or second one is more relevant right now, which is, can we get more explanation of what embeddings actually are? How do they work to enhance the model?
Yeah, that's perfect. Perfect timing. So embeddings are vector representations of any string of characters. And what that means is if you take as an example the words here on the screen, the position of each of these words on this X and Y axis would represent its space, its position in the latent space of this embeddings model. So what you see when you have an embeddings model that's representing your data as these vectors, the points in that space tend to cluster around similar concepts. So we can see on the left here, we have the word tutor, student, school, university. Those are all a cluster because they all have a similar semantic context that would group them into that similar area. And then we have on the right here, in the upper right, we have espresso, cappuccino, sugar, lemon. These are all similar concepts because they're foods or liquids. And so those will be clustered into the upper right. So when you have your knowledge database of whatever natural language you have, it could be encyclopedias, or it could be instruction manuals for how to fix some appliance. If you translate that document or those documents to embeddings and store them in a vector database, the information is all going to be clustered around areas where the semantic meaning of these sentences are similar. So now if a user asks a question and says, hey, my washer dryer is making a weird noise and a red light keeps turning on, that then is going to be translated to an embedding and then compared against the embedding space in the vector database, and it's going to find whichever embeddings in there are most similar and then return those as context. Now, if there's a sentence in that manual that says, hey, if your washing machine starts making weird noises and it starts blinking a red light, the semantic meaning of that is going to be similar enough to the question that that's going to be returned as context. So there are a few techniques that we have to optimize this system. There are a lot of parameters that you can tune to make sure that you're doing this right. So for example, like, how are you going to take that Wikipedia or that manual? How are you going to chunk up the sentences? Are you going to do it by paragraphs? Are you going to do it by every 10 words? There's a lot of different ways that you can change that system to store those embeddings. There's also other techniques called hide, which is hypothetical document embeddings. If you want to go deeper, there's some really interesting research papers on hypothetical document embeddings that can guide you on ways that we see a lot of optimizations for these systems. Was there another question, Marta?
Yeah, the other question that Mike Clemens had was around how are Microsoft users and engineers using LLMs in their everyday work, creating slides, coding? Is it a private or internal trained model?
Yeah, so I can speak to my experience and the experience of just the individuals I talk with. We all have access to the Microsoft Copilot applications. So, for example, in this slide deck, I used Copilot multiple times to suggest ways to format these slides and to suggest ways to like add different content that is optimized for the message I'm trying to get across. There are more banal ways, like autocomplete is becoming really efficient in a lot of our applications. I think that the ways that Microsoft is growing and adopting these large language models in our services is usually in a way that we want to be able to expose to the end user at some point. Like once we feel like we've really nailed it and we've got all of the wrinkles ironed out, we want to have internal people use it just as much as we want external people to use it. So we have different foundation models that can do different things in our Microsoft Copilot stack. And I think that the choice that we use of like which large language models to fuel those copilots is usually just whichever one works best. You want to try them all. I would suspect we're having probably a lot of success with the Azure OpenAI models. I firmly believe that GPT-4 is still state of the art. Whatever magic they're working over there, they created something that is years ahead of its time. And so that I suspect GPT-4 is going to be the backbone of a lot of things going forward.
Very, very cool. There's one more. Sorry, did you want to finish your thought?
No, that's okay.
I guess the question, the kind of follow up from that, or to make sure. So, are you using custom build or like Microsoft only things, or are you using the open, like what I could be using as a random customer?
I can't speak to the models that are being used for these services right now. I think because they're still in development,
right.
I doubt that we have. Yeah, I think that that's something that is likely that we're going to give access to whatever models we use to use our Copilot. We would want our customers to use as well. But yeah, I can't speak with any certainty on that.
Yeah, no, that makes sense. Okay, going back to the embeddings, what tools on Azure would one need to create an embedding of custom data, then create an MPI query that embedding, so that the embedding is always context for my API queries, essentially Azure solutions not requiring LangChain and others?
Yeah, so we're trying to make this as easy as possible because there's so much value from it. So right now you can go to it's called Azure OpenAI on your data, and that will have a user interface where you can seamlessly do all of this document embedding and document and embedding search all in your browser, and of course also as an API that you can use in context coding as well. If you want to do this outside of a browser user interface, you can do this with a combination of the Azure OpenAI Service GPT 3.5 embeddings model, which is a mouthful, in combination with the Azure Cognitive Service vector search. Those two services together will be enough for you to do the embedding search component of this. And then once you get that embeddings context back, what you do with it is up to you. You can put that into GPT-4 with some other prompt context, or you can do any of these other things, seamless transition, that you can do with embeddings. So while using embeddings to hydrate your prompts and your responses and give citations is the primary use case, there's a lot of other interesting things that you can do with embeddings. So you can do just your classic search where results are ranked by relevance. You can do clustering. So this is like higher order. You want to see where different texts are clustered. This could be interesting for things like researching the changes in genre popularity over time. You can also do recommendations where the items that are returned to a querier are items that are related to the text strings that they are looking for. You can do anomaly detection. So this is where if we look back at our embeddings model, or our embeddings X and Y axis, if we had another data point that was like way off to the right, and it was just like a bunch of random strings and characters, that would be embedded far away from these other things because it has the least semantic similarity. So this can be a way for you to do anomaly detection based on the semantic dissimilarity of concepts. You can do diversity measurement, so where the similarity distributions are analyzed. If we go back here, if these clusters were closer together or if these clusters were further apart, that actually means something in the context of the semantic similarity of these concepts. So you can analyze how different these clusters are or how similar they are together and extract some meaning out of that. Finally, we have classification where text strings are classified by their most similar label. So I think one of the best outcomes of this new era of AI is the bar for expertise is being lowered significantly. I like to say that, like, for the first time in my career, I am more excited to use AI than build AI. I was always interested in building the models and training the models. That was the part of AI that just kept me the most intellectually stimulated. I'm actually fine not training models anymore. I haven't trained models in a while, now that I think about it, because I'm so stimulated by the capabilities of the models that are already trained. Like GPT-4 has been out for months now, and I feel like we've barely scratched the surface of what these models can do. So I've created this graphic to kind of introduce these different levels of complexity around how we interface with large language models. At the very bottom here, we have prompt engineering. I think a lot of people here will understand what prompt engineering is. You know, it's optimizing the way that you interface with large language models by giving them prompts that return responses that are most desired. It's pretty intuitive. Actually, I would say extremely intuitive, given the ways that we have been interacting with computers previous to this. And so that is sort of the lowest bar of expertise, is just like figuring out the right way to ask these models questions in their prompts. The next level of complexity here is the retrieval augmented generation, which I talked about before, where we are going and fetching the relative information to provide into the prompt as context to answer a user's questions. And the last level of complexity here on the top is fine-tuning. And so fine-tuning is reserved for when we need to add semantic context to a model that it doesn't already have. And I'm using my words carefully there, semantic context. I think there is this intuition around fine-tuning that it's a way to inject data points into a model so it has context of like whatever data you have, you want to train and fine-tune the model on that data so that it's seeing the documents that you are giving it access to. But we actually find that for an incredible number of complex use cases, they can all be solved with these first two approaches. Fine-tuning is the last resort. If a model, like one time that fine-tuning would be necessary that I can think of off the top of my head would be if there is some new programming language that's invented and it has really wide adoption. And we want the Copilot model to be able to understand and code in this new language. That's not new data as much as it is a new semantic context that we need to imbue this large language model with for it to be able to understand this new language. If there's some new Wikipedia article that comes out tomorrow, I don't think that's how they work, but we wouldn't want to fine tune the model on that article because it wouldn't really absorb the context of that model. Instead, what we should do is we should expose that article as a part of the retrieval augmented generation process so that it can be grabbed and used as context. Now, this solves the problem in two elegant ways. One, it completely sidesteps the complexity of fine-tuning. Fine-tuning is computationally, theoretically, and monetarily complex. It's a big process, and it takes a lot of adjustments and a lot of expertise to do. So that's what's one great thing is we completely sidestep that. And the second thing is it's really efficient to update. If we want to add new context to our model, we just add that new context as an embedding in our vector store, or we add it to whatever database our search is being performed over. So it's like an instant update of the context that our model has access to.
Sorry, just to talk a little bit about the retrieval, knowledge retrieval. Is that something? How would I go about it? You know, I'm a fairly basic user of GPT 3.5 and 4. Is it just using a plugin and saying like, hey, GPT, go and research this for me, and then based on the knowledge that you have, answer questions that I'll follow? Or is there something more to it?
Yeah, I think the way that we implement these in practice is usually use case dependent. So sometimes it's pretty easy. You can just do a Bing search and find your relevant context. But a lot of times the knowledge retrieval that we see our customers need is not something that can be indexed by Bing. It's like their own private data that they have stored in their tenant. And so the way that we approach this knowledge retrieval is very dynamic to whatever knowledge it is that we're trying to retrieve. And I think that if you know the context that you're looking for and you have access to that, the way that we configure these searches should be tailored to that use case. So yeah, I don't think that really gives like a fine bullet at the end there, but yeah, it's very use case dependent.
Thank you.
So we have another 10 minutes, but I want to talk a little bit about some of the common advantages and blockers that we see customers coming to the lab. So one advantage we see is if you have access to a large database of reliable unstructured or semi-structured data. So unstructured data is data that's just like natural language that's in a PDF or a Word file. Semi-structured data is something like a JSON or XML or YAML file. If a customer has access to a large database of reliable, I really should underline that word, reliable, unstructured, or semi-structured data, that can be a huge advantage because that data can be used to ground the model in the data's domain. So if you are like a company that works in the legal industry and you have access to a large number of legal documents, those would be unstructured data. that you can now use as grounding to return responses in that legal domain. Another advantage is whenever we have a documented user story and an associated list of hypothetical input-output pairs. So what this looks like is we know what the user who is interacting with this service, we know typically what kind of questions they're going to ask. And we also know in like these hypothetical input-output pairs, we know what the service should, quote unquote, return as a proper ground truth response. So before we even build a service, we want to know what are the users going to ask and how should the system respond. If we go in without that, you kind of don't have a compass. You're kind of just like feeling around in the dark, hoping that the model just starts giving you good responses. If you have this hypothetical list of ideal input-output pairs, it gives you something to build towards. So it's useful because now we can understand how the end user expected to interact with the solution, and that helps frame the technical requirements. The last advantage we have here is having subject matter experts ready to evaluate the output of the solution. So a lot of the solutions that we're building are in very specific domains that, as an AI expert, I don't know if the output of this solution is giving me a good output or not, because whatever domain this service is answering for is well outside my expertise. So we need subject matter experts there who are ready to evaluate the output, because many generative AI tasks have domain-specific outputs that require that qualitative SME analysis. So let's talk about a couple blockers. One blocker is if the data is dirty or unreliable. Pretty obvious, garbage in, garbage out. If your data is full of contradictions, or if it's full of unnecessary data points, that's going to choke up that search retrieval part of your service, and it's going to make it difficult for you to get good responses that aren't tainted by that dirty data. Another blocker, and this one is another one I could spend a full hour on. If we want to query structured data using generative AI. So we have 5 minutes, and this again, I could talk about this for a long time, but I want to talk a little bit about my experience. If we have structured data, which is data that could be in like a table, an Excel sheet, a SQL table, and we want to ask questions about that data using generative AI, turns out it's a really difficult problem. Using natural language to query structured data is a deceptively complex task. And that's because the first step between taking natural language and asking over that structured data, the first task is to translate that natural language into a query language. So whether that's like SQL or whatever query language you use on the table, it's to take that natural language, translate it to that query language, and then run that query on the structured data. That first step there of translating natural language to a query language is difficult because that translation process is complex, and the amount of expertise it takes to validate that translation process, like seeing if the query the query language matches the semantic meaning of the natural language, the amount of expertise it takes to make sure that's happening right is about the same amount of expertise it takes to write that query in the first place. So when we want to query structured data using natural language and these generative AI models, it's usually a task reserved for people who already know how to write the queries, and they just need a way to augment their user experience and give them a first draft of what that query could look like, so that they can validate that that is the right query, so that when they get their response back from the database and the submitted query, they have confidence that that's the right answer. Because if you don't have that expertise to validate that the query language is a correct translation from the natural language, you're stuck with a response from the system that you just have to trust happened right. Like, you have no way to, if you ask a question like, how many ice cream cones did I sell over the past week? And it goes and it queries your database, that's a simple enough question that would probably get it right. But some of these more complex questions, you would get an answer back saying 12. And if you're an end user who doesn't know how the query language works, you have no way to make sure that 12 is the right answer, other than going into the data set and counting it yourself. But at that point, you've completely bypassed the usefulness of this system. I believe AI will and is reinventing every industry. So the opportunity is yours to lead this AI transformation. Go out there, play with these things. If you haven't experimented with some of the OpenAI models, I say immediately after this, go try them out. It's mind-blowing. It's very cool what they can do. Thank you.
Wow, bang on time. There are 3 questions.
Okay.
So since we are recording, I'll just ask those questions, and then okay, I'll give Brendan, let me give you ability to speak so that you can actually ask your question live, and then we can run over maybe a little bit and you can answer the questions for the recording. There you go. Brendan, do you want to speak up?
Sure. Hello, how's it going?
Hello.
One thing that we've been using the Azure OpenAI models extensively, and one thing that's really bothered me and a couple of other users that's noticed it is that when we're using the new GPT-4 models and we ask it what version of GPT you are, it always answers us GPT-3. This doesn't happen in like chat.openai. It only happens in the Azure ones. We've triple checked, quadruple checked the models, GPT-4, GPT-4, 32K, across every single region. It always answers GPT-3, and it just bugs us. Can you make any comment on that?
Do you mean like you're asking it in the prompt what model it is, or you're like asking the API?
In the prompt. So using the chat interface with the Azure OpenAI Studio.
No idea. That is weird. I'm gonna test that out after this. Yeah, no, I couldn't tell you.
Awesome, thank you.
Yep. Okay. Martha, were there any other questions?
Oh gosh, I was speaking on mute. First of all, there was a comment. Thank you for a great source of resources and a great talk. But then also, is it possible to convert structured data into vector embeddings, as most blockchain is data structured?
So structured data, translating structured data to embeddings is, yeah, it is possible. I don't know how useful it would be, because the value of embeddings models is by mapping the semantic context, and I don't think there's really a semantic context in structured data. The structured data is typically what we call heterogeneous, which means like if you take one column and another column and you swap them, it doesn't really change it. You know, like they're all just different columns. As long as the rows stay the same, the columns you can swap. That means there's no semantic similarity between those columns, which means I don't think translating it to embeddings would be very useful. But I also have, this is my first time really thinking about that, so I don't know, I might have an aha moment after this. So that'd be a good question to explore as a collaboration between Web3 and AI people. That might be something worth exploring.
Maybe next session then. Other than hallucinations and deepfakes, what are other risks of using AI? How do we prevent malicious actors from exploiting this technology and manipulating people? I feel like that's like a whole talk that we can do there. So,
Yeah, I don't know if we have enough time.
yeah.
Here at Microsoft, we take responsible AI very seriously. I think that with great power comes great responsibility. So we are doing our best to make sure that the power this brings towards benefit is also being mitigated by the way that we respond to bad actors who want to use these systems. And a lot of that has been mitigated by us gating the service. So like if you want to use Azure OpenAI, you actually have to apply for access. So it's not just anybody can go out there and start using these models. And I think that that's a good first way that we can begin to mitigate that. And then as long-term projections go on, a lot of it is going to be adaptability of us seeing how bad actors are using the models and finding ways to respond to that.
And I believe you're also putting together a consortium for like policing AI, isn't there? Like there was an announcement a while ago that Microsoft partnered with a couple of other companies to do something like that.
Yeah, we have a great responsible AI landing page at Microsoft.
Yes.
You can learn a lot more about the work that we're doing in the field of responsible AI. So if you go out there and you Bing it, you'll find a good responsible AI landing page.
Okay. Well, last question, just one fun and most interesting interaction you've had with this new wave of generative AI.
Yeah, so I play a lot of role-playing games with my buddies. Playing Starfinder right now, if anybody is into that. And one of my favorite aspects of role-playing games is the world building. So with GPT-4, I actually built an entire world in that context, in that prompt, in like a prompt and response format with the GPT-4 model. It has all these different factions, different flora, fauna, ecosystems, really rich history. And what's great is that while I was having this world building experience with GPT-4, it would remember things that we talked about days before that I had totally forgot, and it would bring that back in as part of the story that we were building together. That was when I think I could really feel my brain wrinkling, because I'm like, this shouldn't be possible. This should be decades away that we're able to do something like this. But it's here and it's now. And so I filled up the entire 32K token window with that world building experience. That was, yeah. My wife will tell you I was lost in the basement for a couple days there, just playing around with the world building part.
I'm glad we managed to retrieve you, because that was an amazing presentation. Thank you so much, Connor. I look forward to our next one next month. So if you have any more questions or you're interested, look out on our Twitter and on the invites. You'll get an invite for next month's presentation, and come prepared to that. I hope you all enjoyed it as much as I did. So thank you again, and see you soon.
Yes, take care, everyone. Thank you.